In today's lesson, we're going to talk about segments. And we talked a little bit about what a segment was in the first lesson and how to name one. So now we're going to handle some other things about segments. This is really a foundation for the year. So again, dividing your notes up so that you have a questions column and a notes column. Like I said in the first lesson, I'm going to stop doing this on my notes after the first unit, but you're going to continue to do it all year. So the first thing we'll talk about is the segment addition postulate. Remember, if you can't get all this down and listen to me at the same time, pause, copy it, then listen. And it's not always necessary to copy all the words. Get the important stuff, which you feel is important. And if you have questions about what's important, make a note over here and I can help you with that. It is important to know what the word postulate means. And this is something in math that we just accept is true. It's something that nobody's ever been able to say it's not true forever, really. We just accept that it's true and we use it to our advantage in math. So the segment addition postulate is just saying that if we take a segment and chop it up into smaller segments, we can get the measures of those small segments, add them up, and they'll tell you how long the original big segment was. So we have this picture here, and this is a picture we're going to see often, where we have a segment EG. So we have this whole thing, segment EG, and we put point F on segment EG, and it breaks it up into two smaller segments, segment EF and segment FG. Now, I've shown you here that segment EF is 13. Remember now, if I don't put a symbol on top of EF, that's telling me the length of EF is 13, and the length of FG is 10. So what the segment addition postulate is telling us is that if we add these two lengths, the lengths of the two smaller segments, then we should be able to get the length of the entire thing, the distance from E to G. And I've written down here, this is what it looks like in symbols. So if you don't know where to start, you can always start by writing that the length of EF plus the length of FG is equal to the length of EG. And I highly, highly recommend you writing this before you start plugging numbers in. Now I know I can plug 13 in for EF. I could plug 10 in for FG. I don't know what EG is. Do a little addition, and I figure out that EG is 23 long. So again, this might have been a really simple example, but when we get to some heftier examples, some things that are a little more complicated, this first step here is really helpful. So I'm going to show you an example that's a little more difficult. This is about the level we need to be on. It's going to involve some solving equations, and then I'll have you try one on your own. So here we see that the length of JK is 48, so that's the length of this whole segment. And we have some labels here. JH is 4x minus 15, and HK is 2x plus 3. So we can start by writing an equation, knowing that these two smaller ones, the length of JH plus the length of HK, should equal the length of JK. And now the best thing to do is just to plug in what we know. We know that JH is 4x minus 15. We know that HK is 2x plus 3. We know that JK is 48. So now we need to do some simplifying on the left side of this equation, and then we'll solve and get x, which is what we were asked to find. Now, if you're a little rusty on solving equations, be sure to ask me some questions in class or stay after school and get a little bit extra help. We just combine the like terms. We have 4x and a plus 2x. That gives us 6x. We have a minus 15 and a plus 3. That gives us minus 12. I'm going to add 12 to both sides. Then I'm going to divide both sides by 6. And I'm going to get that x is equal to 10. So we use this initially to help us out. We set up and solved our equation, and we found out the answer, x is 10. If we wanted to check ourselves, remember now, we could plug 10 in here for x, to 10 in here for x, simplify each of these. So let's do that. 4 times 10 is 40, minus 15 is 25, 2 times 10 is 20, plus 3 is 23. 25 and 23 does give us 48, so we've got a correct answer here. So I want you to pause. I want you to pause your video at home. I want you to get this copied down, and I want you to try this problem with no help first. And then when you're stuck, or if you found the answer, I want you to press play, and I'll go through the answer. So we have these two smaller segments that equal the entire segment xz. I'm just going to plug in what I know. I end up with 2a plus 8 equals 50. I'll subtract 8 from both sides and get that 2a is 42. Divide both sides by 2 and get a is 21. So remember now, if you got stuck somewhere, you don't know where I wrote something down, go ahead and write you a question over here so that you can ask me in class. Another important piece of segments is the midpoint of a segment. And the midpoint of a segment is exactly what it sounds like. It's the point that's right in the middle of the segment, and it divides the segment up into two smaller segments, and those segments are the same size and the same shape, so you guessed it, they're congruent. Remember our congruent symbol right there. So if I have this segment AB, and I have M, and I'm told that M is the midpoint, I know some things about this picture. I know over here that segment AM is congruent to segment MB. And remember, I can show that by putting those slashes there. I know that AM is congruent to MB. And if I know two segments are congruent to each other, then I know that their lengths are equal. So we'll use the congruent symbol when we're talking about segments, just their size and shape. And we use the equal symbol when we're talking about their lengths. So here, segment AM is congruent to MB, and that means that the length of AM is equal to the length of MB. So the midpoint, again, divides that segment up into two equal segments. So I'll do an example with you, then I'll have you do one on your own. Here we're told that T is the midpoint of SU. So right away we can go ahead and say, well, ST and TU are congruent. And I can even write that down. ST is congruent to TU. If ST is congruent to TU, I also know that the length of ST is equal to the length of TU. And I think you might see where we're going with this. We can plug in 3x plus 3 for ST, 2x plus 9 for TU, and we can solve this equation. I'm going to start by subtracting 2x from both sides. We get x plus 3 equals 9. And then I'll subtract 3 from both sides, and I will get that x is 6. So now if we were to plug x back into both of these spots over here, both of these expressions should simplify to be equal to the same thing, since t is the midpoint, and those two segments should be congruent and have the same length. So let's check that. 3 times 6 is 18, plus 3 is 21. 2 times 6 is 12, plus 9 is 21. So we're good to go. Again, go ahead and pause here, get this copied down, try this problem of your own, and then I will have the answer written. So just like the last one, we'll say those two segments are congruent because I know that T is the midpoint. That means that their lengths are equal. And now I can fill in the equation. And last but not least, I'll solve this. I'm going to subtract x from both sides first. Add 6 to both sides. And divide both sides by 3. And again, just like on the last one, if I plug x in here for both of them, if you want to do this on your own, you can. Both st and tu should simplify to be the same number because they should be congruent. Now, again, I'm not showing all the solving steps. You might be a little rusty. It's been a long summer, but if you have questions, be sure to write these down. Like, I don't remember what happened from this step in yellow to this step in orange. Could you please remind me? And I can do that for you. So here are your two you-do problems. They should look very similar to the problems that we did in the lesson I did for you and you did by yourself. So use those as an example. Do these two problems, and you can check your answers at the beginning of class and get full credit for your notes because that's what you want to do.